Okay, hi everyone, welcome back to this video on Windows Server 2012, Understanding Secondary Zones. In Windows Server 2012 R2 DNS, you have the ability to use secondary DNS zones. Secondary zones are non-editable copies of the DNS database. You can use them for load balancing, also referred to as load sharing, which is a way of managing network loads on a single server. A secondary zone gets its database from a primary zone. A secondary zone contains a database with all of the information as the primary zone, and it can be used to resolve DNS requests. Secondary zones have the following advantages. A secondary zone provides fault tolerance, so if the primary zone server becomes unavailable, name resolution can still occur using the secondary zone server. Secondary DNS servers can also increase network performance by offloading some of the traffic that would otherwise go to the primary server. Secondary servers are often placed within the parts of an organization that have high-speed network access. This prevents DNS queries from having to run across slow wide area network WAN connections. For example, if there are two remote offices within the Stellacom.com organization, you may want to place a secondary DNS server in each remote office. This way, when clients require name resolution, they will contact the nearest server for the IP address information, thus preventing unnecessary WAN traffic. Understanding Active Directory Integrated DNS. Windows Server 2000 introduced Active Directory Integrated DNS to the world. This zone type was unique and was a separate choice during setup in Windows Server 2003. This zone became an add-on to a primary zone in Windows Server 2012 R2. It works the same way. After choosing to set up a primary zone, you can check the box labeled Store the Zone in Active Directory. See Figure 2.6. Disadvantages of Active Directory Integrated DNS. The main disadvantage of Active Directory Integrated DNS is that it has to reside on a domain controller because the DNS database is stored in Active Directory. As a result, you cannot load this zone on a member server, and small organizations might not have the resources to set up a dedicated domain controller. Advantages of Active Directory Integrated DNS. The advantages of using an Active Directory Integrated DNS zone well outweigh the disadvantages just discussed. The following are some of the major advantages to an Active Directory Integrated Zone. Fault tolerance. Think of an Active Directory Integrated Zone as a database on your server that stores contact information for all your clients. If you need to retrieve John Ryan's phone number, as long as it was entered, you can look it up on the software. If John Ryan's phone number was stored only on your computer and your computer stopped working, no one could access John Ryan's phone number. But since John Ryan's phone number is stored in a database to which everyone has access, if your computer stops working, other users can still retrieve John Smith's phone number. An Active Directory Integrated Zone works the same way since the DNS database is stored in Active Directory. All Active Directory DNS servers can have access to the same data. If one server goes down or you lose a hard drive, all other Active Directory DNS servers can still retrieve DNS records. No additional network traffic. As previously discussed, an Active Directory Integrated Zone is stored in Active Directory. Since all records are now stored in Active Directory, when a resolver needs a TCP IP address for J. Smith, any Active Directory DNS server can access J. Ryan's address and respond to the resolver. When you choose an Active Directory Integrated Zone, DNS zone data can be replicated automatically to other DNS servers during the normal Active Directory replication process. DNS security. An Active Directory integrated zone has a few security advantages over a primary zone. An Active Directory integrated zone can use secure dynamic updates. As explained earlier, the dynamic DNS standard allows secure-only updates or dynamic updates, not both. If you choose secure updates, then only machines with accounts in Active Directory can register with DNS. Before DNS registers any account in its database, it checks Active Directory to make sure that it is an authorized domain computer. An Active Directory integrated zone stores and replicates its database through Active Directory replication. Because of this, the data gets encrypted as it is sent from one DNS server to another. Background zone. Loading allows an Active Directory integrated DNS zone to load in the background. As a result, a DNS server can service client requests while the zone is still loading into memory. Understanding stub zones. Stub zones work a lot like secondary zones. The database is a non-editable copy of a primary zone. The difference is that the stub zones database contains only the information necessary, 3 records, to identify the authoritative DNS servers for a zone. See Figure 2.7. You should not use stub zones to replace secondary zones, nor should you use them for redundancy and load balancing. Global name zones. Earlier in this chapter, I talked about organizations using DUP-WINs to resolve net bias names, also referred to as computer names to TCP IP addresses. Even today, many organizations still use WINs along with DNS for name resolution. Unfortunately, WINs is slowly becoming obsolete. To help organizations move forward with an all DNS network, Microsoft Windows Server 2012 R2 DNS supports global name zones. These use single label names, DNS names that do not contain suffix such as .com, .net, and so on. Global name zones are not intended to support peer-to-peer networks, workstation name resolution, and they don't support dynamic DNS updates. Global name zones are designed to be used with the servers. Because global name zones are not dynamic, an administrator has to enter the records into the zone database manually. In most organizations, the servers have static TCP IP addresses, and this works well with the global name zone design. Global name zones are usually used to map single label CNAME alias resource records to an FQDN. Zone transfers and replication. DNS is such an important part of the network that you should not just use a single DNS server. With a single DNS server, you also have a single point of failure, and in fact, many domain registrars encourage the use of more than 2 name servers for a domain. Secondary servers or multiple primary Active Directory integrated servers play an integral role in providing DNS information for an entire domain. As previously stated, secondary DNS servers receive their zone databases through zone transfers. When you configure a secondary server for the first time, you must specify that the primary server that is authoritative for the zone and will send the zone transfer. The primary server must also permit the secondary server to request the zone transfer. Zone transfers occur in one of 2 ways: full zone transfers, AXFR, and incremental zone transfers, IXFR. When a new secondary server is configured for the first time, it receives a full zone transfer from the primary DNS server. The full zone transfer contains all of the information in the DNS database. Some DNS implementations always receive full zone transfers. After the secondary server receives its full zone transfer, subsequent zone transfers are incremental. The primary name server compares its zone version number with that of the secondary server, and it sends only the changes that have been made in the interim. This significantly reduces network traffic generated by zone transfers. The secondary server typically initiates zone transfers when the refresh interval time for the zone expires or when the secondary or stub server boots. Alternatively, you can configure notify lists on the primary server that send a message to the secondary or stub servers whenever any changes to the database occur. When you consider your DNS strategy, you must carefully consider the layout of your network. If you have a single domain with offices in separate cities, you want to reduce the number of zone transfers across the potentially slow and expensive WAN links, although this is becoming less of a concern because of continuous increase in bandwidth. Active Directory integrated zones do away with traditional zone transfers altogether. Instead, they replicate across Active Directory with all of the other AD information. This replication is secure and encrypted because it uses the Active Directory security. How DNS Notify works. Windows Server 2012 R2 supports DNS Notify. DNS Notify is a mechanism that allows the process of initiating notifications to secondary servers when zone changes occur. RFC 1996. DNS Notifies uses a push mechanism for communicating to a select set of secondary zone servers with their zone information. When their zone information is updated, DNS Notify does not allow you to configure a notify list for a stub zone. After being notified of the changes, secondary servers can then start a full zone transfer and update their local copies of the database. To configure the DNS Notify process, you create a list of secondary servers to notify. List the IP address of the server and the primary master's notify dialog box. See figure 2.8. The notify dialog box is located under the zone transfers tab, which is located in the zone properties dialog box. So here you see figure 2.8, the DNS notify dialog box, figure 2.9, DNS zone transfers tab. Configuring zone stub transfers with zone replication. In the preceding section, I talked about how to configure secondary server zone transfers. What if you wanted to configure settings for stub zone transfers? This is where zone replication scope comes in. Only Active Directory, integrated primary, and stub zones can configure their replication scope. Secondary servers do not have this ability. You can configure zone replication scope configurations in two ways. An administrator can set configuration options through the DNS snap-in or through a command line tool called DNS CMD. To configure zone replication scope through the DNS snap-in, follow these steps. Click Start, Administrative Tools, DNS. Right-click the zone you want to set up. Choose Properties. In the Properties dialog box, click the Change button next to a replication. See figure 2.10. Figure 2.10, DNS Zone Replication Scope. 5. Choose a replication scope that fits your organization. Advantages of DNS in Windows Server 2012 R2. DNS is Microsoft Windows Server 2012 R2 has some great advantages over many other versions of Microsoft DNS. Here are some of the improvements. of DNS in Windows Server 2012. Some of these became available in Windows Server 2008, but they have not been improved upon. Background zone loading, support for TCP/IP version 6, IPv6, read-only domain controllers, global name zone, DNS socket pool, DNS cache looking, DNS security extensions, DNS SEC, DNS devolution, zone level statistics, record weighing, net mask ordering, DNS update proxy group, Windows PowerShell support. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.